In this video, we're going to learn about the cumulative binomial function. So far, we've always been looking at the probabilities of specific outcomes. For example, if I'm throwing basketball shots at the basketball hoop, questions like what's the probability that I get exactly 7 in or exactly 3 in? The cumulative function helps us work out things like what's the probability that I get up to 8 or up to 4. So that would be 0 or 1 or 2 or 3 or 4, that sort of thing. Let's have a look at this question here. Let's see how far we can get, and then I'm going to show you how to use the calculator to do the whole lot for you in one go. So Bim and Joe play each other at badminton, and for each game, independently of all the others, the probability that Bim loses is 0.2. Find the probability that in 9 games, Bim loses fewer than half of his games. Okay, remember, always best to start with the distribution. So what is the distribution? Well, the number of games that Bim loses has a binomial distribution. There are 9 games, and the probability of losing each one is 0.2. Now, we're looking for the probability that he loses fewer than half. Well, half of 9 would be 4.5, so he can't obviously lose exactly 4.5. So fewer than 4.5 is less than or equal to 4. So he should be losing fewer than or equal to 4. Now, if you're ever stuck on kind of how to set that up, don't feel scared to just write down some numbers. I'm a big fan of doing this. Just here's the kind of outcomes that there could be, and here's half. So fewer than half is less than or equal to 4. It's all of these. Okay, now if we were to actually work this out by hand, we need to work out the probability of 0 or 1 or 2 or 3 or 4, which is way too much effort. Luckily, calculator comes to hand and does it all for us. Have a look. We go to our calculator and it's it's the menu, and then scroll to the distributions, option 7. Now, before we always used option 4, which was binomial probability distribution, but now I want us to use the cumulative distribution. So if you scroll down, it's option 1, binomial CD. Once again, we're always going to go with variable, never list. Now, x is the number that we want the probability up to, so it's up to 4, less than or equal to 4. N is the number of trials, 9, and probability is the probability of success on each go, which is 0.2. And here's our answer, given to us all in one go, 0.9804. 0.9804. So just like that, that's it. Nothing else to work out. Full marks. Okay, so what would have been a lot of work is now quite easy using this cumulative function. Let's take a look at another example. I recommend you pause the video and see if you can figure this one out for yourself, just to see if you can. All right, a bag contains a large number of counters, of which 15% are coloured red. A random sample of 30 is selected and the number of red counters is recorded. Find the probability of no more than 6 red counters in this sample. All right, so what's our distribution? Well, our distribution, the number of red counters, has a binomial distribution. There are 30 counters in our sample, and the probability that each one is red is 0.15. Now, what are we looking for here? We're looking for the probability of no more than 6. Now, if you stumble on the wording here, don't worry, just write yourself out a bunch of numbers that covers the point you're interested in. Now, no more than 6. So not more than 6. So these are the ones which are more than 6. So not those, it's all of these. So what we want is the probability that the number of the number of red counters is less than or equal to 6. i.e. it's 0 or 1 or 2 or 3 or 4 or 5 or 6. So what is that? Well, back to our calculator. All right, so this is our old answer, so just AC to clear that away. And we need to put in some new information. So x is 6 because it's less than or equal to 6. N is the number of trials, which is 30. P is the probability of success, which is 0.15. And there's our answer, 0.8474. 0.84 7, 4. You'll see that I pretty much always go with 4 significant figures here, if I can. All right, so really that's it. That's how we use the cumulative function. In the next video, I'm going to show you how you can use that in slightly trickier wordings. So far, we've only looked at the probability of less than or equal to, so after that, we'll look at more than or equal to. So I'll see you there.